Okay friends, today we will discuss about the Kirchoffs voltage law. Now before we discuss the Kirchoffs voltage law, we have to see what is basically Kirchoffs voltage law. Before we apply it on a circuit, we will see what is the Kirchoffs voltage law. So Kirchoffs voltage law says that the voltage at some junction is equal to all output voltage. This means that if we have some junction or node and we have say two input voltages, that is V1 and V2. Now according to the Kirchoff's voltage law, it says that V1 plus V2, that is two input voltages, will be equal to all the output voltages. Say here we have V3, V4, V5 and V6. So V1 plus V2 will be equal to V3 plus V4 plus V5 plus V6. Or we can also say that the net voltage around the node is 0 or around the circuit is 0, because when we place left hand side to the right hand side, the sum will be equal to 0. That is V1 plus V2 plus V3 plus V4 V5 plus V6, it will be equal to 0. So this is the Kirchoff's current law. Kirchoff's voltage law. Now further moving, we will discuss it in the circuit. We will take this circuit, a simple circuit we will take. Say this is the positive terminal and this is the negative terminal. Now the voltage, say here is 10 voltage, and we will take the random value of the resistance, say 254 we have selected, and the current here flowing is I. So what we have to do, we have to calculate the current around this closed loop or the circuit. So before we start the Kirchoff's voltage law, here we will use Ohm's law, which is V is equal to IR, that is the voltage drop is equal to I times current, the resistance. So the say when the I current is flowing towards the resistance 2, there will be voltage drop, and there will be now a new voltage, okay, from here, and there will be some current, but the current, that is I, will be same. Why? Because the circuit is in series. Actually there is no node, so current will not get divided. So at 5 ohm resistor, the current will be again I. At 4 ohm resistor, the current will again be I. So how will we calculate the value of I here? Say if we move in a clockwise direction, that is this direction, we have to take sign convention into account. This means that if we are moving along the direction of the current, then the voltage drop here, we will take that voltage drop in the negative sign. So negative sign when we are moving in a clockwise direction, or that is in the same direction as current. If we are moving opposite to the direction of current, then there will be positive sign, that is opposite direction. Okay, so these two laws apply for the only for resistors where we have the voltage drop. Now in the battery, if we are moving from negative terminal to positive terminal, we will take the sign as positive, and if we are moving from positive to negative terminal, we will take the sign as negative. So further we will move towards the circuit, and just remember this Ohm's law, that is V is equal to IR. Negative sign when we are moving in a clockwise direction and the current is in the same direction, then we will take negative sign in the resistor, and positive sign when the current is opposite in the opposite direction. So let's begin to solve the circuit. Say here we are moving from, at the voltage source 10 volt, we are moving from negative to positive if we move clockwise direction. So we will take this as plus 10 voltage plus. Now why I'm saying we don't know whether it will be plus or minus, so we won't write right now anything. Now further, if we are moving in the clockwise direction, that is like this, the I is flowing in the same direction, that means we have negative sign here, and we also know here V is equal to IR, that is voltage drop is I times the resistor, that is 2. And again in the 5 ohm resistor, we are moving in the same direction as of current, and there will be again negative sign I times the resistance, that is the voltage drop there. And again we are moving in the same direction, the resistor 4 ohm, so again it will be minus I times 4 resistance, and this net voltage will be equal to 0 as per the Kirchoffs voltage law. So 10 this will be equal to minus 5 plus 4 9 10 11 minus 11I equal to 0. So 11 minus 11I will be equal to minus 10, or I will be equal to 10 by 11. So this is the current which is flowing around the circuit without being changed. Because why it's not changing? Because the circuit is in series and we don't have anything in parallel. When there is any node, the current gets divided, we have to calculate the current individually. So this is the Kirchoffs voltage law in the series circuit. In the next topic we will discuss Kirchoffs voltage law in the parallel circuit, and after that we will discuss Kirchoffs voltage law in both series in the combinational circuit, that is in both series and parallel circuit. Okay, thanks, bye.